Hi friends, welcome to the Unit R Day 5 notes. Today we're going to be going over examples 7 and 8. So with example 7, here we've got 5 over n plus 2 minus n minus 3 over n squared minus 4. Again, we're going to factor each of these. So if I factor n plus 2, it's n plus 2. If I factor n squared minus 4, that's a difference of squares. That's going to give me n minus 2 and n plus 2. So again, off to the side, what I'm going to write out is what the left side needs and what the right side needs. So left and then right. So then, looks like my left side needs the n minus 2, and the right side needs nothing. So when I go through and multiply this, what I'm going to have is 5 over n plus 2. And then I'm multiplying both the numerator and the denominator by n minus 2 over n minus 2. And then now, minus. Now this is a part I'm actually going to denote and show with this minus sign. What we're going to do, again, is change it to a plus, and then we're going to change the signs of everything afterwards. So we're going to change this to a negative n, and then plus 3. So now when I have this here, I've got plus negative n plus 3 over n minus 2. I don't know why I put an x there. Sorry. I apologize bringing my x in. I need to leave my x alone. N minus 2 and n plus 2. Okay. So now, we don't need to multiply anything on the right side. So now I can go ahead and multiply. With here, we're distributing the 5. So this is going to end up with 5n minus 10 all over, minus n plus 3 all over n plus 2 and n minus 2. Now I can simplify. 5n minus n is 4n. And then negative 10 plus 3 is negative 7, so 4n minus 7. And then over here on this other side, we just have n plus 2 and n minus 2. Seeing that 4n minus 7, there's no greatest common factor, anything I can factor out of that, we're done. And again, for these values, n could not be plus or minus 2. 8. So with 8 down here on the bottom, we've got b squared over 4a squared minus c over a. So if I factor everything from the 8, what I end up with in the denominator for this first one is 2 times a, and then just an a in the denominator for the second one. So for my left-hand and right-hand side, my left-hand side needs nothing because it already has the a that the right-hand side needs. The right-hand side, however, needs, looks like a 4 and an a. So 2 times 2 and then an a as well. So going through and doing that, so my numerator here is b squared over, I'm just going to go ahead and combine these as 4a squared, and then minus, okay, now remember, minus, change that to a plus, change the sign of that to a negative, so plus negative c over a times 4a over 4a. Now, we can multiply all of these parts here because we're multiplying by 1. 4a over 4a is 1. Now when I simplify, I get b squared minus, looks like I'm taking 4a times c minus 4ac, and then it's all over 4a squared. In this case, a cannot equal 0. So those are those two. So you can see that these kind of last two here were kind of deceptively easier. And it is when you have less things that you need to multiply each of the sides by. So, kind of going through with that. All right. Next, we've got complex fractions. So this is fraction within a fraction, or I like to call it fractionception. So to figure out what we're doing here, we're actually going to kind of split up in each of these. We're going to think about it in terms of the numerator and the denominator of each part, and then we can go through and get essentially the fraction and then kind of simplify it down. So there's a lot going on here. One of the big things that we need to note is we need to get common denominators in each of these parts first. So I will actually call the numerator of the large portion here. I call this the numerator of the top and the denominator of the bottom, and that tells you kind of which one we're focusing on. So for number 9, we're going to focus on the top portion first. So that's the 2 over 3m minus 3 halves. And so to multiply through here, 2 over 3m, and then this is missing the 2 that's needed, that's on the other side, so I'm going to be multiplying by 2 over 2, and then minus, again, changing that to a plus 3 over 2, and then I'm multiplying by what the other side has. The other side has a 3 and an m. So 3m over 3m. Again, we're multiplying by this because this is the convenient form of 1. If I simplify this, what I end up with, oh, sorry, I missed a negative here for the 3. So when I simplify this, 2 times 2 is 4. So I have 4, and then minus 9m all over 6m. So now I've created I combined and I've created a single fraction for this top part here. And then now I can work on the bottom part. So this is the 3 over 4m minus 1 over 3m squared. So for this one, I have 3 over 4m. So what it's missing that the other side has, it has a 3, and it also has an additional m, because m squared. So I'm going to be multiplying by 3m over 3m. I have a minus sign as well, so I'm going to change that to plus negative 1 over 3m squared. So it looks like it's missing, the other side has a 4, so I'm going to be multiplying both of these by 4. So 4 over 4. All right, now I can simplify this. So this is going to give me 9m minus 4 over, looks to be 12m squared. All right, so now I have my top and my my bottom of these large ones. So these are the large ones that we had here. So 4 minus 9m over 6m divided by 9m minus 12 over 12m squared. Okay, now that I've combined these, and I have just a singular fraction in the numerator and a singular fraction in the denominator, what I can do now is I can multiply by the reciprocal. If I write this out horizontally, remember this fractions can be written as the division symbol. So when we have that and we multiply, remember when we have fractions and we're dividing fractions, we actually multiply by the reciprocal. So if I write this out, it's the same as 4 minus 9m over 6m divided by 9m minus 4 over 12m squared. And remember, when we're dividing, we need to multiply by the reciprocal, so I need to take the reciprocal of that second term. So I end up with 4 minus 9m divided by 6m. So nothing changes in the numerator. Nothing changes in this large numerator here, or this first fraction that we have here, times 12m squared over 9m minus 4. All right, so going through, it looks like that I can simplify this. There's a few things that I can do. I see that I have a 6m and a 12m squared, so I'm going to, the 6 and the 12 can cancel. I'm left with a 2 here. This m can cancel with the squared there, so I'm just left with an m here. So now it looks like this 4 minus 9m and this 9m minus 4 are very similar. They just have opposite signs. What you can do is you can factor out a negative. So what I'm going to do is I'm going to factor out a negative sign from this 4 minus 9m right here. So what does that leave me with? If I factor out a negative 1, I'm left with a negative 4 plus 9m. So that's going to be in the numerator here. Again, if I change the order, I have negative 1 times, in parentheses, 9m minus 4, which is exactly what's in the denominator over here. So I want to point that out, because what's going to happen when I rewrite this is we're going to have, again, some more canceling. So this is the same thing that's right here. So this is that. They're all equivalent. But negative 1 times, in parentheses, 9m minus 4. I've canceled everything out here in the denominator. I'm going to put 1 as a placeholder. Over here in the numerator, I'm just left with a 2 and an m, and then also a 9m minus 4. So now I can cancel these out. And what I'm left with is beautiful. Negative 1 times 2m is a negative 2m. So that entire complex fraction there cancel down negative 2m. and m cannot be 0. Whew, that was intense. That was more intense than camping. All right, I'll see you in the next video where we go over number 10.